Okay, we're also going to be looking at multiplying with square roots. There's a couple of different ways you can do this. The first way is if you're multiplying square root of 3 times square root of 2. That can be written under the same radical. So you can do 3 times 2, and this would be square root of 6. And that's all you can do with that one, because you know that 6 is just a 2 and a 3, and there's not pairs there. You need a 2 of a kind, okay, to have a group of things that come out from underneath your radical. 6, it's a 3 and a 2. You don't have pairs of anything. Okay, number 2. Now, when you multiply these, you'll notice that the 5 and the 3 are on the outside. They're kind of like coefficients to the radical. So you're going to multiply those together. So 5 times 3 is 15. And then your square root pieces can be multiplied together. So in this case, it's a 2 and a 3. So this would be 15 square root of 6. And that is simplified as far as you can go. Okay, number 3, square root of 5 squared. So again, a couple of different ways you can think about this one. Well, anything squared means it's that thing times itself. So root 5 times root 5. Well, those can go underneath the same radical. Well, look at what you've got. You've got a pair of 5s. So that pair of 5s can come out, and that just equals a 5. The other thing you can think of is the square root and the exponent of 2, those cancel each other out. So here, square root of 5 squared, well, the squared cancels out the root. What's left is the 5. Okay, number 4, 5 times the square root of 4. Well, square root of 4, that's a perfect square. That's 2 times 2. So square root of 4 is 2, so I can simplify that. Now I have 5 times 2, and that's 10. Okay, number 5 here. Okay, so similar to number 3. So we just talked about how if I square something, that cancels out the square root, which is true. However, be careful on this one, because the 7 also gets squared. So everything inside of here gets squared. So the 7 gets squared, and then you have the square root of 2 that gets squared. So the 7 squared is 49. And the root 2 squared, well, the exponent of 2 cancels out the root. So that turns into a 2, and that would multiply to a 98. Okay, the other way you could think about this one, and this maybe you'll like this way better, I could think of this as 7 root 2 times another 7 root 2. Okay, because I'm squaring it, so it's that times itself. So there you have the 7 times 7, which gives you the 49. And then the root 2 times the root 2 would simplify to that 2 again. So you would get that same answer. Okay, number 6. Okay, so I have the 2 and the 5. I'm going to multiply those. That's going to be 10. And then I'm going to have the square root of 3 times the square root of 6. So I can multiply that together. That's 18. But then I'm going to use a factor tree to break that down to see if I can find any partners that I can group together. Okay, so you might just want to leave it at, hey, 3 times 6, because 6, you know, is going to be factored down to 3 and 2. So I end up with a 3, and a 2. So under this radical, I have the 3, and then the 6 is a 3 and a 2. Well, there's that pair of 3s. So that pair of 3s can come out. So you already have a 10 out front. The pair of 3s come out. The square root of 2 stays because it doesn't have a partner. So 10 times 3 is 30, and then root 2. Okay. Number 7, same thing. You've got the 2 and the 4 that are out front, so that's going to be 8. And now I have a square root of 3 times another square root of 3. Well, there's your pair of 3s. That comes out, and this simplifies to 24. Okay, number 8, 7 times square root of 2 squared. Now this is kind of similar to what we did this one above it, number 5. Okay, but notice this time the only thing that's getting squared is the root 2. Okay, so the 7 is going to stay a 7. The root 2 gets squared, so that becomes 2. And then we are at 14. Okay, number 9, 5. And then I have the 2 times the 8. So again, I can take this 8 and start breaking it down. This one, however, 2 times 8 is 16. So square root of 16. So you might say, well, that's a perfect square. I don't have to mess with the factor tree. And you're right, you don't. So 16 is a perfect square. You know that that's 4. So 5 times 4, and you get 20. Okay, here's 2 more Pythagorean theorem ones when we talked about this yesterday. But here's a couple more examples, and these are going to be a little more complicated because look at the how I've written the lengths of the sides. Okay, but this is your hypotenuse, so we're going to do our a squared. So root 5 is going to get squared, plus b squared, so root 7 gets squared, equals c squared. Okay, my exponent of 2 cancels out my radical. So this is 5 plus, same thing happens here, 7 equals x squared. So 12 equals x squared. So I'm going to square root both sides, square root, square root. And so now, can I simplify this? Okay, so x is going to equal the square root of 12. Okay, think factor tree. 12 is 4 times 3. 4 is a 2 and a 2. And I'm just going to bring this 3 down. Okay, so look, here's that pair of 2's that can come out front. So the pair of 2's come out front. The 3 is left over. And so our simplified version of square root of 12 is 2 root 3. All right, number 11. Now, this one, we're not looking for the hypotenuse. We're actually looking for one of the legs. So this is going to be 3 squared plus x squared equals 3 square root of 2, and then I got to square this. Okay, so this is 9 plus x squared. Now this gets squared, so that means the 3 gets squared. That turns into a 9. And then the root 2 gets squared, so the exponent of 2 cancels out the root, so that actually turns into a 2. So this is 9 plus x squared equals 18. To solve, I'm going to move my 9 over. So this would be x squared equals 9. So now I'm going to do square root both sides, and x equals 3. Okay, so the side of that triangle is a length of 3. Okay, and that does it for today.